Hi, yeah, so we're going to rip through this one pretty quick. Once you get the basic idea of a hypothesis test, everything else is just details, how the hypothesis test will work. So we already know the hypotheses here. The null hypothesis is that the mean for men is equal to the same mean for women. I'm going to write it like this. So the mean for men and the mean for women are equal, so the difference is going to be 0. The alternative hypothesis will be that the mean for men, we want to know the claim that women have more Facebook friends than men. So the alternative hypothesis will be the difference, but the mean for men minus the mean for women. Since we are testing the hypothesis that women have more, then this difference will be a negative number. So it'll look like that. I think I might have set it up backwards on the other sheet, but that's the same info. Well, in order to test this hypothesis, we're going to use this as our piece of data. We're going to look at the mean from our sample of men minus the mean from our sample of women. And it just so happens that if we were to take hundreds and hundreds of samples like this and look at the mean of one sample minus the mean of the other, they would be normally distributed. These things would be normally distributed, and the standard deviation would be given by this. The standard deviation of that difference would be equal to the square root of the standard deviation of the population squared over n1 plus the standard deviation of the population squared over n2. That's a formula for the standard deviation of this difference. So these standard deviations are the standard deviations of the population of men and women. And once again, remember, we're going under the assumption that the difference between the distributions for men is the same as for women. So we can use this standard deviation twice, once for men and once for women. So that tells us that our test statistic, our z-score, is going to be this. It's going to be the difference, x1 for men minus x for women. That's the actual sample statistic that we get. And then that's going to be minus our null hypothesis, 0, all divided by that standard deviation, sigma squared over n1 plus sigma squared over n2. So this is very similar to our old friend, the z-score, when we took x minus the mean divided by the standard deviation over the square root of n, where this was the standard deviation for this random variable, and this was the mean under the null hypothesis for this random variable. Well, here's the mean under the null hypothesis for this random variable, and here's the standard deviation under the null hypothesis for that random variable. So let's pull out the calculator and actually get some numbers here. Here's my calculator. First of all, I want to find out what x for men minus x for women is. X bar for men minus x bar for women. It says that for men the mean number is 113.4 and for women it's 148.3. So 113.4 minus 148.3. So that's going to be what goes on top of my z-score. That's the difference between men and women. What goes on the bottom of my z-score, well, I'm going to take that and subtract 0 from it. And then what goes on the bottom of my z-score is that formula that you see. So let's take that same answer and we're going to divide it by the square root of the standard deviation squared. And one more time, the standard deviation that we looked up on Google was 43.8. So 43.8 squared divided by the sample size for men. Sample size for men is 48. Minus 43.8 squared divided by the sample size. The sample size for women was 45. So this is our z-score, the difference divided by that strange looking standard deviation. Oh, I see, I forgot something. I did something wrong here. Instead of subtract, that should be a plus there. Okay, so let's try it. We get negative 3.84. Negative 3.84. So we get a z-score of z is equal to negative 3.84. Now that is a lot of standard deviations away from the mean. That tells me that this is a rare event, that under the null hypothesis, this would be an unlikely result. The difference that we got would be an unlikely result. So in this case, we would reject the null hypothesis. If we want to figure out what our p-score is, or p-value is, we have a distribution that's centered at 0, standard deviation of 1, and we want to figure out what the area to the left of that. This is a left-tailed test. Sorry, let's go up here. It was a left-tailed test, so we want to figure out the area to the left of our test statistic, negative 3.84. Real quickly, to do that, clear this guy out. We're going to do the normal CDF from negative infinity, so that's my negative infinity, all the way up to negative 3.84. And that's going to be under the, with a mean of 0 and a standard deviation of 1. It tells me 0.00006. So the p-value is, this area is 0.00006. Very small. Very easy to reject the null hypothesis. So at the alpha is equal to 0.05 significance, this is much smaller than alpha, so we can safely reject the null hypothesis. That went longer than I thought it was going to.